This video is going to go over reasonable domain and range of quadratics. Alright, so with quadratics, when we're graphing them with Desmos, there's an infinite amount for domain, right? There's no restriction. The graph goes on forever and ever. So as in the problem for the previous assignment, if you look, like it keeps going on forever and ever. Whereas in real life, when we're throwing a basketball, when we're kicking a soccer ball, when we're putting a golf ball, right? These things, they don't go on forever and ever. Once you hit it, eventually it's going to hit the ground or it's going to stop. So this problem, a soccer ball is kicked on a box that is 4 feet from the ground. So if I look at this graph here, okay, looks like the ball starts, right? It gets kicked up in the air and then eventually lands on the ground. So it looks like the x-axis is our horizontal distance in feet, and then the range or the y values is your height in feet, so how high the ball gets, and then the x-axis is how far the ball gets. Okay, now with domain, okay, domain is our x values. Now if it's our x values, we want to look along the x-axis, okay? Now domain being our x values, we know that it's restricted on both ends. So I'm going to put an x in the middle, okay? And then I'm going to have two numbers on both ends telling me where I start from the left to the right. Remember, domain, you want to go left to right. You always want to go left to right for domain. Okay, so let's start on the x-axis. The most left the ball is how many feet? Well, on the x-axis, remember on the x-axis here, we're looking at x-axis for domain. So the most far left it goes is at 0. It starts 0 feet away from the person. That makes sense. So the farthest it starts away is, or the closest it starts is 0, right? The ball starts 0. Well, then how far does the ball get? Sorry. How far does the ball get from the person? Well, they kick it, and then it goes, and then it goes and goes and goes, and then it lands how far away? At 14 feet. Remember, for domain, you're looking at x values, so I'm only looking on the x-axis. I don't really care what's going on up here. I just know that it's going to go from 0 feet, and then it gets kicked all the way to 14 feet away. So the number on this side is 14 feet. Now, you're going to have inequality signs in between this, and it's always going to be less than, right? Because 0 is the smallest number, so 0 is less than everything. And then 14 is the biggest number, so it's going to go over there. So you're going to have two less than signs. Well, can the ball be equal to 0 feet away? Yes. Can the ball be equal to 14 feet away? Yes. So for our domain, remember, you want to look on the x-axis, and you want to go from left to right and look at those two numbers. For your range, it is your y values. And for range, you always want to go from bottom to top. And the reason why you want to do this is because you always want to start small and then get bigger. Now again, with range, we're going to be restricted, right? This is a real world problem. It's not going to go all real numbers on us. So we're going to have y in the middle, and we're going to have two numbers to the left and to the right. You always want to start on the left side. So that's going to be bottom to top. Well, if I'm looking at this graph, okay, what's the most bottom this graph goes? And you might be like, well, the most bottom is right here. But that's not true, is it? Because if I look, it hits the bottom here. So the height vertically, the height of the ball, right? It could be 0. It could be on the ground. You got to remember this person was standing on a box that was 4 feet high, right? So that's why the ball starts up here and not on the ground. But eventually when they hit the ball, or they kick the ball, it goes up and it hits the ground. So here, the lowest y value is technically 0 because it's 0 when it hits the ground. So the most bottom is 0. Again, you might want to put 4, but remember that's not the lowest bottom. That's not the most bottom the ball goes, okay? You want to go the most. And then let's look at the top. Well, what's the highest this ball reaches? Well, it looks like the ball reaches a little bit over 10. I wouldn't say 11 because 11 would probably be right here. So let's just say like 10.2 or something. Let's just round. I don't know. So the highest the ball gets is maybe 10.2 feet. Is that the most accurate answer? No, but it's a good estimate. Okay, remember, range is bottom to top. And remember, this is reasonableness. You don't want to think about it like, well, they start at 4, so the most bottom the ball gets is 4 feet. That's not true because they can kick the ball and it can land below them at 0 feet. So the range goes from 0 feet on the ground all the way to 10.2 feet high. Now you want to put your less than signs because you're always going to have less than. the ball is or can be equal to 0 feet from the ground, and the ball can be 10.2 feet from the ground. So it can be equal to on both. And then the last question, at what height does the ball start at? Now this is a combination of reading the problem plus looking at the graph and analyzing it. Well, I know that the height of the ball doesn't start at 0 feet. It definitely starts at 4 feet. Okay, so the ball starts at 4 feet high. And again, for the range, you don't want to say that it starts at 4. Some of you might think that, but it doesn't. Remember, when you're looking at bottom to top, you're looking at the most bottom, and then you're looking at the most top. For domain, you want to look at the most left to the most right. And that is quadratics and domain and range of reasonable problems.